string comparisons, passing arguments. So that is what we done. And today we'll focus on file operations. So basically, file operations is an important aspect of your shell scripting. So definitely you will come across a situation where in the automation you'll feel that okay, this is required. So this concept will come into automation on demand, guys, because the concept is on files. So the file operations you're supposed to use in the if condition, and these are the operations they have given. So if you say -f, it can tell you whether regular file or not. -d, like directory. Likewise, -r, read permission. -w, write permission. -x, execute permission. So I'll do one sample and show you how this can be helpful for us. Let me start the machine. Okay. So NMTUI, activate a connection, activate with hostname -I. It is 12. .192.168.1.12. So I got the access. Okay. So let's see, guys. So cd into the scripts. You can see it is last example was 16. So we'll do example number 17 on file operations .sh. So /usr/bin/bash program on the use case of file operations. Echo, enter the file name to check if it exists or not. Read file underscore name if square bracket -e dollar file underscore name. Okay, if it exists, then echo the file, the dollar file underscore name exists. Else echo the dollar file underscore name does not exist. Then if I save this and close. So chmod u plus x, example number 17, sudo sh, example number 17. So enter the file name. So I'm entering the file name wantedly something called india.txt. It checks in the current path. So we know that India file does not exist. But same thing, if I enter the file name that says example number 3 hyphen shebang.sh. We know that this file exists. See, it is telling the file exists. So the file operator called -e is helping us to know whether file exists or not. So if you're planning to expand this logic more, we know that this file does not exist. What we'll do, we'll say, go. We are about to create the file now. I'll say sleep for 10 seconds. So sleep is a Linux command which will pause the operation for 10 seconds. So it is something like pausing the action by 10 seconds. So this line gets executed. Then after it will wait for 10 seconds and then it will proceed to the next line. So next line is I'll say touch dollar file underscore. It will create the file. Echo. Now check the file underscore name is created. Yeah. So we return the logic. So generally in the file operations, if it is positive, the first block, if it is negative, we write the block here. So I return some logic to check whether file exists or not. If it does not exist, it will create it. Save this and close. Okay. Then execute this. So I'll say india.txt. We know that india.txt does not exist here. See, it's saying india.txt does not exist. We are about to create the file now. Yeah, the file got created. How do you verify? Just check it. See, india.txt got created. I'll do one more time. So this time I want to create russia.txt. So that does not exist. We're about to create the file now. So you can check russia.txt got created. So that is what the use of this file operations. We'll do one more example, guys. So before we do that, please take down this into your book. So let me know once you guys have written this, guys. Okay, so I see Arjun has done. How about Divya, Kavya? Okay. So I want you guys to give one more try. So let's try this. So I want you guys to write a program. So this is a question exercise. Please give a try. Exercise is check if the file has execute permission for user or not. Okay. Display the info actually. If it there, if it is there. If it is not there, if it is not there. So if it is not there, then go ahead and give the execute permission. So this is the question. You can give a try. And here are the operators. I kept both on the screen. So I want you guys to give it a try, guys. So exercise. See, one of the operator will be helpful to get this done. So please give it a try. So check if the file has execute permission for the user or not. If it is there, display it. If it is not there, also display it. Then expand the logic further, saying if it is not there, then go ahead and give the execute permission. So I'm guessing for this logic, 3 minutes of time is sufficient. So please give it a try, guys. 3 minutes. So I want you guys to give it a try. 3 minutes of time. I'm expecting some of you guys can do it. This is not big deal, as the question itself is easy. So any progress from your side? So I think Nayak Rajat has given some code. So where is the code, man? You written half. So definitely appreciate the people who have at least giving a try. Give a try, guys. Until unless you try, you never know your strength. Okay, only I got half from Nayak, but let me try, guys. So VI example number. Okay, I got the code from Prithviraj. So let's see. So this is the code he has given. Read the file underscore -x. No, logic is missing, but effort is great. Almost effort is great, guys. I'll copy his program and put it here. So escape I, shebang statement. So /usr /bin/bash program on use case of. What is the use case? File operations only. So I'll copy paste this program and make necessary changes. Yeah, echo is here. For checking the file, okay, enter the file name. We'll modify this. Enter the file name to check if permission per user present or not. So just making it better. That's the only thing. Okay, then he was reading the file name. That's nice. Then he was using -x. So yeah, execute is -x, but here dollar file name you need to give. Space is also required because these are all rules here. Then so he was saying simple mistake here. The file has permission to execute. Okay, fine. Else, and what he was telling. So the file. Okay, so let me correct this. The dollar file has no permission to execute. Okay. Then what next line you're saying? So the dollar file name has no permission to execute. Okay, so let's make it better. Okay. Then he said sleep for 10 seconds. That's okay. Then why touch? This is what not required here. Touch is to create the file. No? Our target is to not to create the file, to give the execute permission. Now this is where your knowledge of Linux is required. So now you tell me, guys, what is the Linux command which will help us to create the execute permission in Linux? What is the Linux command I want? Command I want. So question is simple. Since you have done, yeah, that is where chmod is required. Chmod u plus x. Can I say $_ file name? Is it going to work? That is our target, no? Yeah. So chmod u plus x for that file, I want to give the permission. Then I'll say echo the $_ file name execute permissions are given. Then we'll say if I. That's it. Save this and close. Let's give it a try. So we know that on India file, there is no execute permission because for user, there is no X here. So let's experiment on it. So it's asking the file name. I want india.txt. So there is some error in the code. So let's try. Where is the error? Second line, third line, it's good. Fourth line, it's good. Here. Yeah, so let's give it a try. So India.txt. India.txt has no permissions to execute. So we are about to give the execute permission. So it sleeps for 10 seconds. Then it does it works and confirms that execute permissions are given. Verify it, ls-l. You see India.txt turned to green color because user has been given execute permission. So I hope you understood the program. So please take down this. So definitely the file operations are very useful in your automation script space. When you write the logic, this will come in handy. Please write this program into your book. So is it done? Please confirm. Okay, fine. Now let's see the next thing. Okay, case condition. So what is this case condition stuff? So case is one of the conditional statements here, like if. So if is also conditional. So if it is positive, then true block will execute. If it is negative, false block will execute. So based on expression here, right? So that is what if does, but case is little different. So the people who have little knowledge on C, C++ or any other programming languages, they would find this a similar use case there also. So in C language also we have, C++ also we have this, right? Case conditions. So case, what we'll do is we give some expression here. Okay, expression. So based on the expression, so if the expression is matching, let's say 1, it will execute whatever the code is given here. Let's say expression 2, it will execute whatever the code is given here. Expression 3, it will execute whatever code is given here, right? If the expression is not matching, so let's say we call it as default. So if none of the expression is matching, then it will go to the default condition. It looks like then we have to close this, guys. So once it is done, we say ESAC. Now this case expression somewhat looks like our normal life example I'll give you. So let's say you purchased a train ticket. Okay. Train ticket can be classic example for this. So at the time of booking, right, you will just know your train number, right? And you know your seats number. That's it. But you'll never know the platform. So what happens is on the day, you will visit the railway station. And what happens is they will try to tell you on which platform it is. So now the case. The train may come on platform 1. The train may come on platform 2. And the plane may come on platform 3. Right? If the, let's say if it's not coming to the 1, or if it's not coming to the 2, or if it's not coming to the 3, then definitely we'll check with the staff there, service guys there, service desk. So what has happened with the train? Is it cancelled or is it getting delayed? So that is what you need to understand the logic here, that expression matters. So if the expression says you have to visit platform 1, then based on platform 1, accordingly, the things will happen. If it is platform 2, accordingly, the things will happen. If it is platform 3, accordingly, the things will happen. Am I clear on this, guys? You need to understand the logic behind it. Okay. So even in the, when you visit the hospital, also same story, right? So in hospital, what happens is receptionist, she will take your registration. She will ask you to please go to the room number 1. Okay, let's say you're suffering from fever. So let's say you tell them that, okay, I'm suffering from stomach pain, or let's say bones problem. She may ask you to visit, what is that guy? Bones doctor, we don't know, orthopedist. Yeah. Visit the room number 5. Okay. So let's say you have some, let's say, not fever or not bones problem. So let's say you have problem with the eyes. Then they ask you to visit room number 8, ENT doctor, right? So the condition is based on expression. Based on expression, we are visiting the appropriate rooms to meet our doctors. The same logic applies here. So we'll try one example so that you will understand what I'm trying to do. So we example number 19, case condition .sh. So in the same example, I'll try to write the arithmetic program also, guys. Program on the use case of case condition. Let's say echo. Well, let's say menu. So after I'm done with this program, I'll tell you my experience that I faced in a hospital, a small clinic, where they were using the same case condition program to get their program executed. Okay, I'll tell you one small story on this. So 1, addition, echo. 2, subtraction. Echo. 3, multiplication. Echo. 4, division. Echo. 5, modulus. Now echo, enter your choice. Either you should enter 1 or a 2 or a 3 or a 4 or a 5. Okay, I'll read that to the key. Whatever you enter, it will go and sit in the key. Now see how the logic is. Case dollar key, whatever you enter. Okay, in. This is a part of condition only. So case dollar key in. If it is matching with, let's say you entered 1, because whatever you enter, that will go and sit in that key. If you entered 1, then you have to say then. So this forward bracket is called then actually. So if you enter 1, then don't write the code in the same line. That's a rule. Please leave that line and write the code in the second line. Okay, remember this point. The same line, please don't write. Then you say read -p, enter a value, a underscore value. Read -p, enter b value, b underscore value. Now echo the value of a plus b is. How you do the calculation? This is the calculation possible in. This is the standard calculation in bash scripting. You need to put dollar, open double brackets, and say a underscore value dollar of a underscore value plus dollar of b underscore value. That's it. So this part is calculation based, and dollar will print. So I used dollar here to print, but this part from here to here, it's a calculation stuff. So they echo the value of a plus b, so it will print. Then you'll say this 2 semicolons to say that the block is over. You need to put 2 semicolons to say the block is over. Then we'll write the second block. Second block is for subtraction. So I'll copy the same logic and put it here. And only I need to do is I need to update the minus symbol. Here also it is minus. Third block, we know the same code, but we need to put this is the multiplication. So we'll put asterisk symbol into symbol. Then fourth, we are trying to do the division. So a by b. Done. Then fifth is modulus. Same copy paste. So modulus means percentile, percentage symbol. So here it is. It will go and come like this. Then if none of the case, let's say you did not enter 1, 2, 3, or 4, or 5, you're entering something crazy 10, 20, then we'll write default. So default should be written with star. Star is a symbol you need to use. Star. Star is nothing but default. Then we'll say echo, you have entered a incorrect choice. Okay, echo rerun script and enter a valid key. That's it. Then we'll close it. ESAC, reverse. Case letter should be written reverse. That's it. Save this program and write it. So first one is addition. So 1, enter your choice. So it's asking the enter the A value. So let's say 20. B value is 30. It is 50, right? Then let's execute. Second one, subtraction it should do. So 30 minus 20, it should be 10. Third is multiplication. So 5 into 5 should be 25. Yeah. Then fourth one is division. So 10 divided by 2. So what is the result, guys? 10 divided by 2, how much? So easy. How much it is? 10 divided by 2. It's a 5. So the output is 5. Okay. Same program. Now this time modulus. I'm trying out modulus. So again, 10 by 2. Now what is the result? How much you'll get? So 10 by 2, how much it will get, guys? So first of all, I want to know how many of you are not aware what is a modulus, so that I'll tell you what it is. If you know, then give me the answer. Please raise your hands if you're not aware of modulus. So 10 modulus 2, the answer will be 0. Guys, the answer will be 0. How come it is? So remember, division, see, 10 divided by 2, the answer is 5. That means this is nothing but quotient. Okay, that is what division symbol will do. Okay, again, same 10 divided by 5. We know that it is 5 only, the quotient. Now, but what is the remainder here? In this calculation, what will be the remainder? 0. So modulus will track the reminders. That's a difference. In computer science, simply remember only one logic. In computer science, division will get you the quotient and modulus will get you the remainder. That's it. I hope you know it now. Am I clear? Ranga, Kavya, Kirtis, Aunika, Pavan. So this you have to be careful, guys. So if you're not aware, please write somewhere on the notes. In computer science, when you ask the computer, please do the division, it will get you the quotient. Okay, the same computer you ask, please get me the modulus. It will get you the reminder. So it is common in entire computer science space. Whether you learn Python or C or C++, Bash scripting, PowerShell, it's common everywhere. So this logic, don't forget. Modulus focuses on the reminder. Division will focus on the quotient. Okay. So now we'll try one more last time. We enter the value called 8 option. There is no option called 8 here. We know because our key should be 1, 2, 3, or 4 or 5 only. If I'm entering other than these values, then it will trigger the default case. See, it went on to the default and says, you have entered an incorrect choice, rerun the script and enter a valid. Clear on this program? Rohini, Samir? Yeah, please take down this, write this into your book. Let me know when to scroll the screen, guys. Okay, I'm scrolling little down so that you guys can write. Please write this. So is it done? Okay, so I hope it is done. Now let's move on, guys. And let me see what's next. Okay, using EXPR. Fine. I'm trying to copy this program to experiment something. CP example number 19 as example number 19 only. But this will go as 20. EXPR. Yeah, I'll open up example number 20 and make some changes. So this program same case condition, and we are using EXPR for arithmetic calculations. So for arithmetic calculations, guys. So there is something called EXPR. So what is this EXPR step? So whatever I'm going to write, that is specific to the bash scripting, what you just saw earlier program. So this way of calculation will work in bash scripting, will work in what you can say SH scripting. It will work in TSH, KSH, everywhere. But this way of writing, this is special to, like this will write, guys. We'll say dollar of EXPR or like this. So this will go inside. That's it, nothing else. Everything is same. We'll remove one bracket and we'll say EXPR. The end we remove. So this is specific to the bash scripting. This will only work in bash scripting. This will not work in other type. Okay, there is one more problem here is in EXPR, plus is a plus, minus is a minus, division is a division, modulus is a modulus. But there is one concern in the into multiplication. So in the when you're using the EXPR, into should be written little somewhat different. So you should not write directly like this. You should write somewhat like this. Is it like this or I don't remember? Just let me check. Yeah, backslash star unit, right? Yeah, we written backslash. See, normally we write into, but here please make sure that you put a backslash and put into symbol. So that's the meaning of multiplication in EXPR. Okay. So let me try. So sudo sh example number 20. First one addition 10 plus 10, it's 20. Second subtraction 50 minus 25, 25. Third is multiplication, which is little different. We know it. So it is 10 into 10, it should be 100. Yeah, working. So fourth one is division. We know 100 divided by 5 is 20. Then modulus. Now this is interesting. 10 divided by 3. How much you'll get, guys? What will be the modulus now? What will be the modulus for 10 by 3? So it will be 1. Reminder. That's what I told you. Modulus will catch the reminder. So it will be 1. And if you're entering anything other than those numbers, so let's say 99, 99 option does not exist here. It says you're in correct value. Yeah, please take down this program also. Please write this also. So you should know how to write both also using XPR and standard calculation process. I'm scrolling little down. So is it done? Okay. So it seems it's done. So let me close this. Fine. So let me see what's next is while, and the next we'll have for loop. Okay. So let's do it. While we'll try to end up the bash scripting today. Okay. So what is a while here? So while condition. So you can see here. So we write the while and we get this is also conditional statement, guys. Like if also is also conditional. Case is also a conditional only. And this is also conditional, but it is in the format of a loop. So what happens? Let's say you given the condition here. Okay. So where is this pen? Okay, it's not working. So let me use this. Okay. Thickness. Too much it is. Yeah. So let's say you return some condition here. If the condition is true, okay, it will enter the block and it will execute whatever it is given. Then it will come back and checks again. That's the reason it is called loop. So again, it checks the condition. If the condition is true, again it will enter. Again, it will execute. So this will keep on executing until the condition fails. So the moment the condition is false here, then it will stop executing this block of statements. So I will write one sample to make you understand first. Then we'll do little different. So this is while condition dot sh shebang statement slash usr slash bin slash bash program on use case of while condition. Okay. So what we'll say? So I'm wantedly writing. See, I is equal to 1. Okay, let's say I is equal to 1. While square bracket $I value is less than or equal to. You remember hyphen LE, guys? Do you remember LEGTs? I think I told you yesterday, right? So LE, if it is less than or equal to 5, okay, then do, because you need to follow the syntax. So here it is saying, please write do. Okay, so do that. So do what? Echo the value of I is $I. Then I need to make sure that it will enter and it will print this. Then I need to make sure that I becomes 2, because you need to increment. So I is equal to calculation part, same that we followed. So $I plus 1. Same arithmetic calculation process we are following. Okay. Then we'll say done. Now see the logic, guys. It will start with 1. 1 is less than 5. It will print I value. Then I becomes 2 here, because $I is, let me write correctly, I written something incorrect. $I plus, we need to give some space. Okay. So $I is 1. 1 plus 1, it is 2. So 2 gets assigned to I now. So now it goes and checks. 2 is less than 5. It is true. So it will print. So again, I becomes 3. 3 is less than 5. True. It will go. I becomes 4. I is less than 5. Yeah, true. Again it goes. Then I becomes 5. I is 5 is less than 5. That is false. But again here we given equal to. 5 is equal to 5. That is true. It will print 5 also. Then I becomes 6. The moment I becomes 6, this condition. So 6 is less than 5, it's false. So it will stop. This will stop. So that is how things will work. So ch mod u plus x, example number 21. You see? So I value is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? Yeah, it printed. Yeah, click down this program, guys. So this is a simple to make you understand how the while condition works. So is it done? Okay. So let me write one more program, guys. So I want you to write the logic for table program, guys. Table program. Okay. So this is easy to enter 5 and it will to the 5 table like in childhood. 5 into 1, right? 5 into 1 is equal to 5. Likewise, go up to 5 into 10 is equal to 50. Whatever table number that you enter, it should print like this. So let me give a try. So VI example number 22. by cbank statement slash USR slash bin slash bash program on the use case of table printing. So echo, enter the table value to print, read table underscore value. So what we'll do? So we'll say I is equal to 1, same. We'll start with I is equal to 1. We'll say while square bracket $I is less than or equal to 10 because our target is to print 10. Echo. Our target is to print like this one. So that means you should design in such a way that it should get the same output. First is, I think, table value it should print. Then you need to have the into symbol. Then it should print the $I value. Then it is equal to, then close it. Then it should do the calculation. So dollar of table underscore value into $I value. Calculation is over. Then I need to increment the I value. I is equal to dollar of I plus 1. Then I'll say done. So definitely it will print the table now. So hmod u plus x, example number 22, sudo sh, example number 22. Enter the table value to, so it is printing. Yeah, take down this, guys. So please take down this program. The logic is simple only. So here this is a classic example to make sure that we loop it. So is it done, guys? Okay, great. So we have one more last thing. So that we'll try to do tomorrow. One last thing. I want to hurry very. So it will almost take again 15 minutes. Tomorrow. So we'll stop it here for the day. Also, we are going to start the chef. The next tool is chef. So once the chef, I'm expecting that your class will be finished by third or fourth is last, because for chef I require 3 to 4 days, and shells 3 to 4 days of chef. So I'm expecting we should close by 4th April, guys. Okay, so that's the deadline we have. Yeah, that's all for the day, and we'll catch up tomorrow as usual.